Welcome to Embedded. I am Alicia White. Christopher White will not be joining us today, but you know how half of you think that Chris Veck is Chris White? The other half of you think that Chris Gamble is Chris White? Today we have a brand new confusion for you. Our guest is Alicia Gibb, the director of the Open Source Hardware Association. Hello, and thank you for being on the show.
Yeah, thank you for having me.
Could you tell us about yourself as though we met getting ready to go to the Open Source Hardware Association conference?
Absolutely. So I am the executive director of the Open Source Hardware Association. I founded the Open Hardware Summit along with Aya Badir 10 years ago now.
Yay!
So that's a big milestone. And I am really interested in access of information and freedom of information. And that is what I think is the most important thing about open source hardware is just accessing files and plans and knowing how to build something and having the legal rights to build something is really important to me. And so that's why I'm here, and that's why I do what I do. And I wear several different hats. I probably have one too many jobs, but I really love jumping around within my work from day to day. Everything is somewhat related, but it really gives me a different skill set to work on every day and new problems to solve every day, and that really excites me.
Cool. I totally understand. So I want to do a lightning round where I ask you short questions and want short answers, but we'll see how well I do without the how and why and tell me more. Christopher usually keeps a tight rein on this. So. What's your favorite Arduino derivative?
Probably the LilyPad Arduino because it changed how Arduinos work in both form and function.
What's your favorite Lego set?
My favorite Lego set is probably, that's a tough question, probably from the Creator series, the City Hall.
Cool. Mountains or beach?
Beach, even though I live in the mountains.
Favorite thing to blow up or favorite method to blow something up?
Favorite thing to blow up is an LED with a 9-volt battery.
Yes.
And no resistor in between.
It's either that or capacitor gone wrong. Yeah. Hacking, making, tinkering, engineering, or designing?
Hacking.
All right. So now for the longer questions. Tell me about your career. You didn't get into hardware with a traditional EE degree, did you?
No, I did not.
Your background's in art?
Yeah. So my undergrad degree is in art education. And right before I graduated, I decided that I did not want to be an art teacher after doing student teaching. I wanted to have a little bit less chaos in the classroom. And so I quickly grabbed a library sciences certificate on the way out of undergrad. I worked in a library for 3 years in a children's library. I love children's books. And then to be a librarian, you actually have to have a master's. So I went back to get my master's. I went to a program that happened to have both my loves at the time. So it was a joint master's in library and information science and one in art history. So I got 2 masters and I'm using neither of them. But I ended up writing my my thesis on how the Arduino microcontroller is a malleable tool for the arts. And I really, from the library sciences side of things, I really took away that the teachings of and the importance of freedom of information and access to information. And so in my head, it's not like a huge jump from library and information science to open source hardware. I know sometimes that sounds like a crazy path, but I think, I've always loved building things with my hands and doing things, and my art degree was definitely about that. And then I love studying art, and so the art history degree was about that, but it had the electronics component in that because I had figured out what an Arduino was halfway through grad school. The library sciences side of things really promoted that information should be free and accessible and available. And how do we do that within hardware? Well, we open source it. So all three of those things, although they don't automatically seem to fit together, in my world fit together quite nicely.
I can understand that. And I understand the freedom of information being important. I remember like 1998 or something, and Wikipedia seemed like it was just starting. And, it was a time there were lots of technologies changing the world. Mm-hmm. And my carpool buddy and I were talking about what we thought was the smallest thing that would have the biggest impact. And I definitely argued for Wikipedia. The idea that you could have information and that it would be free and that encyclopedias no longer cost many thousands of dollars or were stuck in a library, that you just needed a device and you could get to everything. Mm-hmm. And so yes. And how that applies to hardware, yes. The way we progress is to not build the wheel constantly.
Yes.
Which brings us to the Open Source Hardware Association. Do you usually say OSHW, or do you actually do all the letters?
I usually say OSHW.
Okay.
I'm lazy like that.
That's what I thought it was called, but got to make sure. Why does there need to be an organization? I mean, it's already open source hardware, open source software. There are lots of people already arguing for this. Why do you need formality?
That is a great question. So when we first started the summit, we were kind of, sort of just a couple people, random people that were starting this summit and asking donors for money. And at the time I was working at a company called Bug Labs in New York City. And so we were routing the money through Bug Labs. So it was a little funky to be like, oh, we'll pay this company and then we'll use it for the summit. And, I don't know how the company did whatever books they had to do, but we realized that our donations could be bigger if we were a nonprofit. And that, people wanted not just Alicia Gibb's bank account to dump the money into. They wanted something with a little more teeth. And then we also recognized the fact that in that era, a lot of the open hardware companies were startups. And the nature of startups is that, you can get bought or you can shut down or all kinds of things can happen to startups. So we recognize that working in one place or trying to kind of tie a couple people together who were working at various startups long-term might not be the best solution, and that we needed sort of an umbrella organization that wouldn't go away at the whim of a VC or wouldn't get rebranded or wouldn't go away altogether because of funding issues or whatnot. So those were the initial reasons to start the organization. But since it's grown, I've actually really seen other reasons to have an organization. And those involve really our international landscape. So just to kind of get the word out that, open source hardware is a thing and it's a viable way of business and we can do this and here are the ways to do it. And here's a certification that you can certify your projects or products. I think all of those things were sort of afterthoughts to starting the organization, but really great reasons to start the organization because people know that we're a trusted source and that we've got kind of clout within the community. And larger companies, like your Microsofts of the world and your Texas Instruments of the world, who are not known for doing open source, feel comfortable coming to us and saying, oh, like, this is really interesting. Can you tell us more about open source and how we would do it and how it would work within our current and existing structure? And I think if we were sort of a little bit more of like a cobbled together team that just happened to be working at different companies and whatnot, we might not be as trusted or as unbiased as just our own organization.
I like the idea of TI and other companies coming to you and asking about open hardware, because open source software has had well, here's the license and here's how you do it. And by the way, here are the ways you can open source the code, and here's what it means. And with hardware, I mean, isn't it all open source? Because I eventually can hold it and look at it, but not really.
Yeah.
How do you define open source?
Hardware is tricky, especially, I think, in those larger organizations that already have a very set legal structure to follow. So, with open source software, it's really the legal way to do open source software is baked right into copyright law. So because copyright is automatically given, you can license your product or project as open source software, and it's just already like, that's it. That's all you have to do is open source. The really, in a lot of the companies' hierarchy of intellectual property, they would get a patent, of course, and then license that patent in an open source manner. And the way that the law kind of works, at least in the US, it's not like this everywhere, but in the US, there's a little bit of like a hoop to jump through. So in real, technical terms, and of course, none of this has been tried in court, so we're not 100% sure how this would work out. But, in theory, the law states that you have to first have a patent. Otherwise, without a patent, basically all hardware is intrinsically open source. And once you get a patent, that is when you lock it down and you get to have your monopoly for 17 years or however long your patent is for. And then within your patent, you could license it in an open source way. But a lot of our community doesn't want to go through that giant hoop of getting a patent. Exactly. They're incredibly expensive. They take a really long time to get, and they take a lot of work. And so it seems really counterintuitive, especially in the tech world where things are moving so fast, to wait 3 to 5 years for a patent and spend at least $50,000 doing it when you could be spending $50,000 extra on innovating your product. So there's a lot of inhibitors to, the true sort of legal route of open sourcing your hardware. So we sort of created more or less a hack that we think works. So for one of those things, there's an importance to just a cultural movement happening, and even if a company does not have a patent and chooses to open source their hardware in the way that the open source hardware definition states that you can, and several of the open hardware licenses out there cover, the intention of the creator is very much to open source that. And again, nothing's been tried in court, but that's our hope, is that there's enough cultural clout behind this movement, and there's enough intention behind this movement that, if anything ever happened, that people would say, oh, okay, this was truly meant to be open source hardware, and here's this open source hardware definition, and this is what it means, and this is what they followed. And then, because again, it's kind of this hack, we further created a certification, which is tied to trademark law. So it has a little bit more teeth, in where if somebody was using it incorrectly, like we've seen in the past, a few problems where people will call their product open source hardware because it sounds really great. And it's a little bit like, good for marketing. But then they won't actually release the files or something like that. And so going the certification route, if people certify, that's a trademark that OSHW owns that we could then redact legally from a company who might be using it incorrectly, or a company who might be copying open source hardware without then also releasing the files or following the license chosen by the creator. So there's a couple extra layers that we've tried to add on at the bequest of the community.
Okay, so I think the layers are you have to not only provide the board, but also provide the schematic and the Gerbers and the BOM. And is there more?
Usually, so we don't actually, the BOM is not necessarily considered the source. So usually it's the schematic and the board file will do. And really at the heart of it, because we consider hardware to be, anything from clay pots to food, to medication, to electronics, to 3D printers. So that makes it really hard to specifically say like, oh, you have to provide X as your source, because there's so many different sources out there. So really the test is, could someone else replicate your item? And if the answer is yes, with whatever files you provided, then we consider that open source.
Fair enough. But BOM does come into it, because there are parts that I can't get unless I order 10 million of them.
Right. And that's where, so for example, we don't consider the Raspberry Pi an open source hardware project because that Qualcomm chip is under an NDA, and people, can't get that, and people can't, don't have the money or the resources or the clout to be able to get through Qualcomm's process. So that's true. We don't necessarily need you to release the full BOM, but I think with a lot of projects out there, it's again if people can copy it, that's the best measure of whether it's open source hardware or not. So all the things on an Arduino, for example, are easy enough for any single person to get, that we can easily populate a board and see what's on it and that kind of thing.
And you mentioned international, or actually you said this was all more about the U.S., but there's an international aspect to this. In that
absolutely,
the U.S. thinks that nothing should be copied unless you want it to be copied, and then you should be asked and paid and all of that. But that's not how much of the world works. They don't reinvent things each time.
Yeah. So, and the reason that I talked about U.S. law is just because that's the country that I'm most familiar with. I'm not a lawyer, but in going through all of this open hardware stuff, the country I'm most familiar with, the intellectual property laws, is the U.S. But yeah, I've definitely heard, varying things when I visited, Denmark or Germany or whatnot. And China's got their own IP laws that were actually just put in place in 1984. And yeah, so there's a lot of different kind of flavors out there. I would say there are definitely similarities among lots of the IP law out there, but it's really the differences are the more interesting bits to them, because some of the, the word patent actually appears in our Constitution in the U.S. And I'm not sure if it appears in other, countries' constitutions, but it sets the stage in a really interesting and I think kind of weird way in the United States for lawmakers then to, be like, but it's in the Constitution. You can't, change the structure of patents or whatever. And I think that patents get more stardom in the U.S. because it's in our Constitution, where I think other places the focus isn't necessarily on IP or on patents or kind of hoarding that information. The focus is much more on like, oh, well, let's, make this safe for our customers and make sure it's usable, or make sure that, people want it, or make sure it's somehow recyclable or easy to reuse and there's privacy concerns around it or whatever. I think that other places tend to focus more on those aspects than on the aspects of making sure that, you've got your IP protection for X number of years, which like in technology, again, if you've got a patent for 17 years, I mean, think of like what technology do you use that's 17 years old? I mean, the cell phones weren't even invented, like I think 17 years ago. I don't even know. Or at least smartphones weren't. But yeah, so I think, I think there's a lot of ways that knowing the U.S. IP laws, first and foremost, I feel like they're also some of the strictest. And I feel like if we can change some of the laws in the U.S., we could maybe be more in step with some other countries.
Just to go back there, I did have a sidekick 17 years ago, which is one of the first smartphones.
Yeah, it was kind of like,
as you said that, I was like, when did I get that sidekick?
Right. I was totally thinking like, yeah, there were cell phones before smartphones.
Okay, but to go on to the important bits here, if you mentioned trademark, and I think that's one of the things that is hard to wrap people's brains around. In software, we have copyright, and we kind of understand what that means. It's the right to copy right there in the name. But trademark is different. Trademark is the legal permission to print a logo on something. Is that a good summation, or do you have more nuance?
Yeah. So I think, there's three branches of intellectual property. There's the copyright and patents, and those copyright and patents are meant to protect the creator. Trademark, though, is meant to protect the consumer. So trademark law exists so that you can trust a logo or a brand when you see it. The consumer knows like, oh, okay, that's that particular brand, and I know that, and I trust that brand and whatnot. And that's why it's a problem if you use that brand or that logo without licensing it, is because then you might be putting the consumer in a place where they can be confused about a product. And that's why we consider, you need to open source your software and your hardware, and anything copyrightable and anything patentable needs to be open source. But the trademark does not need to be open source, because that is a company's brand and there to protect the consumer.
And so if I don't know, trademark horse and then stamp it on every horse that I see, because
right.
I have made all the horses. This analogy got really bad fast. But anyway, and then somebody starts stamping horse on zebras. And I'm like, no. You don't understand. I own the stamp horse. And you can't use it because your zebras may not be as good quality as my horses.
Exactly. Yeah, that's exactly what it's meant to be used for. I think sometimes, with everything, right, there can be overreach. And I think sometimes the trademark law can be, sort of used in ways it wasn't intended to be used or whatnot. But I think overall, trademark is still pretty true to, right? Like we don't have trademark trolls out there like we have patent trolls. So I think trademark law is also like, still really in line with like how it should be used and why it's useful.
And so if I'm open sourcing a board and I go through the OSHW process, then I can use the OSHW logo. But I can also put my own logo on there so that if somebody wants to copy my board and make a derivative, they don't get to use my logo because my logo says I built this and you can expect this level of quality from me.
Correct. Yes. So you can use our certification logo if you go through the certification process, and you'll get a certification logo that has actually a specific number to your specific certified piece. And then, within our certification process, we make sure that you're not using the logo of a company if you made a derivative. So absolutely you have to take the logos off of a different company. If you don't represent that company, you can't use their logos, but you can use the OSHW certification logo if you've gotten through the OSHW certification process. And you can also use, there's an open hardware logo out there that was designed for and by the community that's licensed with Creative Commons. And so anybody can use that logo. It's that kind of that gear logo with a little cutout in it. And that logo can be used by anyone. There's no trademark on it. There's no protections and whatnot. But that does make it tricky, right? Because that's where, I mentioned before, like we've seen boards use that logo that weren't really open source and things like that. So that's kind of why we decided to launch the certification with a trademarked logo where we could stop some of that from happening.
And so if I decide to make a board, I could use what is it called? The other logo.
Yeah, we call it the gear logo.
The gear logo. I could use the gear logo on my board and I could tell everybody it's open source. Mm-hmm. But then I could opt never to actually give anybody the thing, anything other than the board.
Right. And we kind of have no legal ramifications behind that logo if that happens. So, and again, this is really speaking to, we want to make sure that there's a quality to the name open source hardware and that the files are behind the project. So that's really why we started that certification.
If someone was considering using an open model for a product company, what kinds of things should they consider? So I think in this question, are you asking a little bit about business models? About business models, about worrying that other people will take your designs and use it without attribution or undercut you or lose your lunch or, are there successful examples of product companies who've used open source hardware? And I'm not going to count SparkFun, Adafruit, or Arduino here because those are education companies.
Sure. So yeah, I think there are absolutely product companies who are successful using open source hardware. I think what changes a little bit is our current business model around hardware has for a really long time used intellectual property as a crutch. So you could design, a camera that may not have functioned very well or may not have been user-friendly, but because you got the patent on it, you could run with that camera and beat your competitors into the ground even though they had better cameras. What open source hardware's business model is really, they look at different reasons that somebody might buy something. So, is it the cost that's important? Is it the quality? Again, going back to that trademark and logo and brand, is it that I trust a particular company and I know their board is going to work when it arrives and I know that I can get tech support if I need it and they have hours available where I live that I can call or text or email or whatever? Or is it like shipping time, right? Do I need it today? Do I need it tomorrow? Is it okay if it takes a month to get to me? So I think instead of thinking through, the intellectual property side of things and how do I, hammer any competition out of the scene, it's much more on like, we know we're going to be copied and that's okay. That's what open source means, as long as it's done correctly with attribution. It's fine. But how can we move faster than the competition that might be out there to create more innovative projects, to listen to our customers and add on or take away features that they've said we need? And how can we make this as user-friendly as possible or as environmentally friendly as possible if that's something that our customers care about? There's a lot of different reasons, it turns out, why people buy things. Personally, I have never once bought anything because it has a patent. I don't think that most people don't look for the patent numbers on the product and say like, I better make sure this product has a patent first. So it's really kind of weird that we have placed so much leverage on a patent as part of our business model. But hardware, and this is one of the ways that open source hardware differs from open source hardware or from open source software, is that the business model overall for hardware kind of remains the same whether or not it's open source, which is you sell something at a higher cost than it took you to make. So, because hardware is a physical thing, people do expect to pay money for it. I think with open source software, people often expect it to be free, even though there's developers' time behind it that needs to be paid for. Open source software free as in money, I should say. Where in hardware, people expect it's a physical thing. They understand it takes work to extract, minerals out of the ground to make that thing. And there's manufacturing involved and people on the line and everything else. And so it seems more obvious to pay money for hardware. So in that sense, the business model is very much the same as open source or closed source. It doesn't really matter. You just figure out what it costs to make your product, and then you sell it for more.
That's tough. I'm thinking about all the companies I've worked at where items were copied, usually consumer goods. And the thing is that there was a hardware cost, and we were selling the hardware for, I don't know, let's call it 4x what it cost us to build. But that 4x, 1x was about marketing. 1x was about the actual hardware. And 1x maybe was profit. We'll call that profit. Great. But there was a big part of it that was the engineering that went into it. The non-recurring engineering, the people who designed it for the first time, who had a dozen boards that they went through, who worked out the physics of making it work. And if you have an open source model, how does that piece get paid for? I mean, take away the profit. That we'll take that away for now, but you still need the initial buy. You still need money to support it and market it. I just don't know how you get the money to make new stuff.
Yeah, I mean, I think that's absolutely like one of the reasons that companies want to get patents, but again, I would say,
or even just not make it open source.
Right. Yeah. Just not share the files and keep it like a trade secret. Yeah. And I think there's a couple, different kinds of lines of thought with that. And for a really long time, I was, that particular argument kept being used in terms of the medical industry.
Yeah.
And I thought, oh, okay, like, sure, like medicine, right? Like, and I don't know anything about making medicine. So to me, that was like, wow, that's a huge black box. And yeah, that takes research and development and like all this stuff. But once I started talking to some experts in the medical field, it was really interesting because they said, there's not really that much, there's the R&D that happens does not make up for the massive costs of drugs. And of course, I'm again talking about drug pricing in the United States. And so there still can be a discord in pricing and the R&D of it. And I think a really great example of this is actually if you look at insulin. So there is an open insulin project going on right now. But if you look at insulin, it was invented like somewhere in like the 1920s-ish, I want to say. And so those patents should have been up a really long time ago. But what happens is the companies tweak just a tiny bit of it and convince the patent office that that's enough of a tweak that they should receive another 17 years or however many years are on drug patents. And they've been getting that granted. And it's, and we've seen when we've heard about the price of insulin just like getting driven up and up where people can't even afford it anymore. So I think that's a really good example of like, I think in certain cases there is R&D, but I think in a lot of cases it's kind of been being used as a scapegoat to say like, oh, well, this is why we need to protect our invention is because it took the R&D funding and it's the non-recurring costs and whatnot. And like I said, I think that in some cases that's absolutely true, but I think it's often, especially when those large drug companies are using it, I think it's often a misnomer when it's trying to get a longer cycle on your patent. I think that in those cases, there's not the R&D costs that are really going into it that need it to be closed, right? Like we'd be in a better place as a society if it was a product that was open sourced where other companies could compete without that sort of man-made initiative of having that monopoly on the hardware to begin with, or, just like sharing that knowledge and sharing that information really can drive products up. And I think what it does is it really creates a competition. And so it's true that you spent the money on non-recurring costs, but then if another company comes out with an open source product, they've probably also spent a little bit of engineering costs on making it better. And you, as the original company, can then take all those things and put it back in your hardware. And we've seen this happen a lot where companies will actually kind of go back and forth with this particular board or piece of hardware where they actually just keep making it better. And they make it better for each other, really. So it's not as much of like the original company creates it and then a derivative is created and that's it. That's the end of the day, right? A lot of times the original company will take the good things about that derivative and fold it into their product. And I think another thing to remember is the world is really big. And so even if I create something in my little corner of the world, on the opposite side of the world, somebody can be creating something that's exactly the same or creating a derivative of that thing, but that's a market that I would never reach. So like, I don't speak the language there. I don't have a website there. I don't have a storefront there, whatever. So that's really unless I'm like, I don't even know a company that's like all over the world. I want to say like Target or something, but they're not even like everywhere. So I think, for instances like that, I feel like products are still in a very localized market, and it behooves us in terms of being environmentally friendly to keep them in localized markets. And so if we, there's been a lot of talk about what's going to happen to our planet. And I think in an environmentally friendly, sustainable kind of way of thinking, and maybe it is that you have to give up some of your products, but if it means you still have a planet in 50 years, that might be a good trade-off. But when you think about like, wouldn't it be better if people could just make the item, make a derivative of my product in their localized market, sell it there, then I don't have to ship anything. So in a way, I think sometimes it can also sort of benefit. I think one thing that Arduino derivatives did was actually make the Arduino itself more popular. So people may not have always gotten into the Arduino world through the original Arduino board, but they got into it through, a various derivative and then worked their way back and saw like, oh, and there's like this whole other microcontroller, original microcontroller. So that's sort of my take on the, making up for those non-recurring costs, or sort of situating that argument a little bit differently.
I have to admit, I'm not convinced.
I mean,
going to medical was probably where you lost me, because it's well known for price gouging, especially in the United States, and ridiculous price gouging. We are in a state of tumult on that. But hardware, I mean, I've worked at a lot of companies, and saying $1 million to bring a small device to market. Yeah. And if you're talking about a medical device, you're talking 5 to 10 million. And if somebody else can just make that.
Yeah. So
it's really hard. It's really hard for engineers.
Right. So, I mean, the other thing about that is, I think for one thing, there's somebody who's going to be first to market, right? And you don't have to supply your source until it's on the market. So you're already getting a leg up because you're first to market. And as long as you can hang on to your marketing, being first to market definitely has some advantages. And I think the other side to that is, there's also an argument for like open sourcing can actually get you a lot of free engineering by the community doing things for you and fixing bugs and all that kind of thing. But I think another really important aspect to remember is that not everyone wants to be a maker. And for a long time, like this took me a really long time.
So true.
It took me a really long time to realize like there's like a lot of people, I think there's more people who just want to be consumers than want to be makers. And they would much rather buy something than attempt, even if it's open source, they'd rather buy it than attempt to build it themselves and to create it themselves. And that kind of ties into the manufacturing process. So especially like in the medical device field and, in a product line, like it's not that easy to copy a product if even if you have the source. When you look at, some knockoffs of products that are patented, you certainly see the differences and you certainly notice that there's differences. And I think just because the source is out there, because we don't consider before we don't consider the BOM part of the source. So you might be using incredibly different parts than the original company is using. You might be using different suppliers. We don't force that you have your suppliers out there. So using a different supplier can make a huge difference in a product alone. And finding a supplier that can create a medical device to the specifications it needs to be is also like incredibly difficult and incredibly expensive. So I think really in that light of thing, when we're talking about, the medical industry and non-recurring price costs, we're talking about maybe Medtronic competing with Boston Scientific. And from my point of view, if those companies have a little more competition, that would be great. Right. But I think that kind of goes for everyone. Like I know that, there is like a lot of fear around if I open source my project, it's going to get copied. And the answer is yes, it very well might get copied. But if you create a product that is, incredibly complex, that takes a lot of those NREs, there's not going to be a whole lot of companies who are, number one, interested in copying it, or number two, can copy it. And by the time they do, they will probably have to put as much work into it as you originally did, finding their suppliers, making sure their suppliers understand and know how to, put everything together and mold everything that needs to be molded or whatever needs to be done. So I think, and that's why I think, a lot of the open source hardware projects right now, I don't want to say they don't have as many NRE costs than, some projects out there that are still closed, but it seems like I should say the products that are that have derivatives, I think, are those projects that don't need as many NREs. So I think a lot of the open source that we see getting copied, correctly and having derivatives have a lower cost to entry than some of the products that are not getting copied. Like the Chumby is a great example. Like that was, an open source project, like, I don't know how long ago now, 15 years ago, 10 years ago. But I've never seen a copy of that. And I attribute that because there's a lot that goes into it. And there's, open source computers that are being made. And again, like, I don't see that as something that another company is going to just be able to come out with in 6 to 12 weeks, right? They're going to need to put some of their own costs behind it. And so I guess that's why I personally don't see that as a big kind of a negative side effect to open source hardware. But I think that there is a lot of fear around exactly that. And in people who aren't quite who are kind of like on the edge of our community and not quite sure if they want to open source or not.
That's what I was trying to get you to do, was to convince me. And I'm not sure you have, although if I have a maker object, if I'm making something a kit, that is something I want people to be able to make for themselves. I work on a little robot system sometimes. And I can totally see open sourcing everything I've done with that. I have so far. And I can see at the end of the day, people wanting the system once it works, which it doesn't, instead of wanting to build it all up the way I have. So that would be an open source software and hardware project. And it would make sense to me because it would be an interactive activity where I expect people to show me bugs and to help me as they can because they're interested and excited and they're makers or they're interested consumers. Mm-hmm. But as I think back to working at children's toys, Leapfrog, and we made educational toys to help kids read. Mm-hmm. The amount of engineering we had to do to start the manufacturing line, the before manufacturing engineering, the recording all of the audio data, the developing the gameplay so it was fun, and then to have that be copied was really hard. And Leapfrog was never a company that would have been a good candidate for open source. But part of me wants to be able to go back and say, look, it's for teaching kids to read. Yes, let's open source it. Let's let everybody have it. But there would have been no profit there. And I don't know how to get over that leap from makers making things and don't need a lot of profit to people doing innovative development, needing profit to continue the innovation. And the only thing people have to copy is their manufacturing line. I don't know how to convince a company they should go open source with that dichotomy, that price difference that they'd lose.
Well, again, I think having the product, like having the IP on the product, is only one reason people purchase products. So just because a Leapfrog got copied would not mean that people would go buy the copy. And it wouldn't mean that Leapfrog would necessarily even lose product. It might even be that somebody would make a derivative, offered a cheaper price. People would use it. People would buy that product and say, oh, okay, this is good, but the quality I've heard in Leapfrog is better now that I've used this one. I'm going to go buy the real one, or like the Leapfrog one or whatever. And it might even actually drive up product or drive up profits. So I think, again, looking at profits and looking at the reason people are buying things is absolutely key to open source hardware. So I've asked this question to a lot of classes that I've lectured in, which is, who looks at the patent number and makes sure there's IP on something before you buy a product? And I've never once had anybody raise their hand to that question. But people will buy it for all kinds of different reasons, for, again, for color, for shipping, for quality, for brand name recognition, for the marketing around it. And I think that that is really why people buy products. And it really has nothing to do with how many copies of anything there is out there. I don't think Lego happens to be hurting just because Mega Bloks has been around. That was very much, a direct copy and attempting to get into that market. But, and I think there's lots of examples of that where there have been copies, but it doesn't necessarily make the original company's profit go away, because people care about purchasing products for different reasons.
Yeah, that's true. I mean, people don't buy Apple products because they're necessarily the best hardware, but because they're Apple products.
Right. And like, there's no reason that Apple needs to, charge as much as they do, but they totally do. And even, you could consider it's sort of a, derivative of BSD. So in that logic, every single person should be using Linux rather than purchasing an Apple computer. And that's just not how the world works.
Yeah. And cost is definitely a consumer driver, but it isn't the only. I agree with that. Let's move on for a bit.
Sure.
The Blow Things Up lab.
Yeah.
Do you actually blow things up? Can I visit?
Yeah, so you can visit. The Blow Things Up lab is a hackerspace at CU Boulder that I direct. Largely, it has a bunch of students, but we do allow community members to join, and staff and faculty, and kind of anyone who wants to be there can be there. It's a very open space. I don't care what major the student is. It's not like you have to be an engineering major. And I think that's actually kind of the beauty of a community and a space like that, is when you get people from different backgrounds helping each other out and helping solve problems. And I always love, the Blow Things Up lab is part of the Atlas Institute. And the Atlas Institute also has this sort of interdisciplinary concept of teaching and interacting. And so students from outside of our major can take our classes and all that kind of stuff. And it's wonderful when I get your art student next to your engineering student trying to solve a project together. And, I had two students working together, and the engineering student had done all the math, and in theory, everything should have worked and whatever. And their circuit wasn't working, and they were super frustrated. And the art student leaned over and just said, "Oh, let's just take a resistor out," right? And just pulled out a resistor, and the circuit started working. And the engineering student was like, "No, wait, don't," but the art student just ripped it out, and it made the circuit work, which is great. It shouldn't have made the circuit work in theory, but in the physical world, it totally made the circuit work. And so, there was some maybe math that was wrong in there or something, but it's great, how the art student just kind of had the confidence to let's just try some other stuff and experiment with some other things, even though, the equations aren't quite working for you or whatever, and I've had the reverse happen where the art student's totally frustrated and can't figure out why their thing's not working. And an engineering student comes over and says this, on your data sheet, the ISET pin means a resistor. And so you have to put a resistor in there or whatever. So having different subsets of knowledge and coming at problems in different ways is really important. But more directly, what we blow up in there. So we try to have it be a space that is safe, of course, but we really try to allow the students to have the freedom to experiment. And sometimes that might mean blowing things up. And so sometimes, that a lot of things, a lot of what we teach in there is the concept of resistance, right? And so that's why blowing up an LED with a 9-volt battery with no resistor in between is my favorite thing, because the aha moment that students get is that's why resistance matters. That's why you need resistors. But we've had some students make some really interesting things that, have at one point put a hole in our wall, and that's fine. Like, that's kind of what the space is for. And as long as like I said, as long as the humans in the room are safe, that's the most important aspect to what we're doing. And as long as the students feel safe, feel that the person who might be doing an experiment that might be kind of questionable or is just an experiment, we don't know the outcome. As long as the students feel comfortable and feel safe, then we sort of give them rein to use that as an experimentation space. And I'll say, a lot of it is more hacking and making than it's not like everybody comes in there specifically to blow anything up. A lot of people come in to use a sewing machine or use the bandsaw or the soldering iron or the laser cutters to create things, not necessarily to blow things up, but it gives sort of the attitude of the space up front and lets students know that it's okay. That's a space where they can really push boundaries and that's okay. And that my job is really to protect their safety, but also to protect their creativity and their desire to do experiments, even though they might be questionable.
I love the idea of allowing some questionableness and calling it the Blow Things Up Lab gives you the freedom to call them experiments.
Yes.
And the idea that college campuses have these is just freakishly cool to me. I mean, I went to a college and we had an excellent metal shop and a great wood shop and a tiny arc welding shop. And I had free range after getting, checked out on everything, but they were shops. I mean, you did not screw around in the shop. You did not play in the shop. You did not run in the shop. You did not wear safety glasses. I mean, there was just, there was the list of rules. And the idea that now you have hacker spaces where you're supposed to break the rules is really cool. Mm-hmm. And people use it for that, right?
Yes, absolutely. I think it's great. What's happened is like a number of student groups have started using it because it's a space, right? And so it works in a couple of ways. It is like a physical space where students can use it as a platform for various things like student groups. Students have taken upon themselves to teach their own workshops. If they discover something cool, they want to, share it and teach other people how to do it. And then it works as a platform as the community. So people can ask each other questions and learn about each other's experimentation, learn what happened or what didn't. I feel like a lot of what we blow up to is motors. Well, either on purpose or not on purpose, but
they're so fragile.
Yeah. Yes.
And
but
MOSFETs.
It's a great learning opportunity because if students do that, it's not like, oh, you blew up your motor. Now it's going to be $400 to replace it or whatever. It's like, oh, well, now you know how to blow it up. So now you know how to not blow it up. So here's another one, and so we really, the whole sort of putting it in this concept of experimentation, I think also allows students to feel more comfortable with making a mistake, which really is what college is all about. It's making mistakes. It's figuring out what works and what doesn't work, or at least I think that's what it should be. And figuring out how to best make something work. And to do that, a lot of times you have to push the limits of things, and you might blow a couple things up on the way. And when that happens, we don't want it to be problematic or costly for the student or, something they did wrong. It's something they did right. They were figuring out something new.
How do you get funding for that sort of thing?
Yeah. So, I get funding from the Atlas Institute. So they fund us. And then we also get funding from companies who are in a line with thinking this is an important learning experience for students. So we take donations.
I'm just jealous.
Yeah. I mean, my experience was similar in that, as an art student growing up in undergrad with art education, there was I got the opportunity to not play around in, but build things in shops. And I got to use a bunch of different tools. And I think it's also really important for all different disciplines to have those hands-on experiences. So When I used to teach like basic intro to soldering classes at NYC Resistor. And a lot of people would come in from engineering programs to learn to solder.
Yeah.
And they would always ask me like, whoa, like what engineering school did you go to that you learned to solder? And I said, yeah, I went to art school. But I think, the college for so long, universities have been situated in this concept of like, we teach theory and you go to a trade school to learn the hands-on stuff. But I think you can't quite do the theory to the best extent unless you really know how to play with the hands-on stuff. And especially like in manufacturing stuff. I mean, I learned so much more when I was trying to manufacture my own thing and more about really what the machines could and couldn't do, even though their specs said something different. There's what's on paper and then there's reality. And those two often don't match in hardware. So I think the sooner students realize that, or the sooner anyone realizes that, who's especially trying to make a project or product, I think the better. So, I'm all for giving people that hands-on curriculum and hands-on experiences so they can learn from those things.
You mentioned a manufacturing experience. You did a Kickstarter for Build-A-Pons, which are Lego light-up bricks.
Yep.
Is that one of the manufacturing experiences you had, or have you had a bunch? Or tell us all about it.
That is one of I would say the most challenging manufacturing experience I had. So yeah, I was making little light-up bricks that were compatible with Legos, and if you know what the secret sauce is of Legos, it's their tolerances. So they are working with incredibly tight tolerances. And the only reason I know so much about the particular medical industry manufacturing is because the only people that could manufacture my parts had to be the medical industry manufacturers, because they were used to working with incredibly tight tolerances and really tiny parts. And, there were so many crazy like restrictions on what I could do, because the reality and what it was on paper didn't always match up. And so making sure, I really wanted to make sure that, of course, these were compatible to the Lego product. And color matched and everything else. And it's incredibly hard to do. And I think that's why, in terms of making a product, I spent a lot on the NREs, but there's a big part of me that doesn't care, because I know that somebody's going to have to spend just as much on the NREs if they ever wanted to take my source and create a derivative. And so, because I know how hard it is to even find a manufacturer that will talk to you, because you have to go with these incredibly, tight manufacturing guidelines. And so it forces you into the medical manufacturing industry, where most manufacturers are just going to tell you, no, we do medical devices. We're not doing a toy. We're not going to put that on our line. This is ridiculous. So just finding a manufacturer alone was an incredible challenge. And then every single step of the way was another challenge, and none of the source is going to help you with that. None of the source is going to tell you that. So, and maybe my product is particularly complex, although I think there's a lot more products that are complex out there. And that's my thought process is well, whatever. Yeah, I spent some on MREs, but everybody's going to have to. But yeah, it was very eye-opening into the manufacturing world and what it really takes to create a product.
Did Lego contact you? Have they said anything about them?
No, they totally don't care. I am way too small, and I think they think it's silly, and I don't know that for sure, but I actually tried contacting them, and I think they have their bread and butter down so in such a tight manner that, number one, I don't think they want another company's weird like they have no interest in swallowing up another company's weird invention to their product, because they're like, okay, yeah, that doesn't reach our standards, and there's no way that we like I've heard like the numbers of like what they want their profit cycles to be or something are like completely bonkers, and so there's no way they could make these cheap enough. There's ways that, like I can make it cheap enough because I don't care about having, 20% versus 30% profit. Like 20% is perfectly fine with me. And I think they also, like until maybe I get really big, which I don't know that, I don't know if there's really that many people that care about lighting up their Lego projects, but I really want mine lit up. So it was a product I made for myself. But, my Kickstarter, I felt like proved that like, okay, well, there's 650 other people out there that care about it. And maybe that's it. Maybe it's a niche market. And that's totally fine with me if it's a niche market. But that wouldn't be fine with Lego. So I think, they're really going after those like big ticket items where other companies, and I've seen a lot of, ever since their patent was up in 2012, I've seen a lot of various different types of innovation around Lego. Even if it's just kind of like creating different weird bricks that they don't create. And again, I kind of feel like they don't really care, and they're not a very litigious company in that way, because I think they realize like, even if people buy those other derivatives or whatever you want to call them, it's not going to stop them from buying Lego. And most of the products out there are kind of like complementary to Lego anyway. And so you still have to have the Lego kit to use all these other products. So it actually like kind of benefits them and behooves them to allow a bunch of other random people to sort of create these, their own derivative thing and variation on it, because it only forces more people to buy the actual original product.
Before I let you go, I want to ask you about a book you edited, Building Open Source Hardware, DIY Manufacturing for Hackers and Makers.
Yeah.
Could you give us the 2-minute spiel for that?
Yes. So that is really meant to be sort of a written guide of all things that touch open source hardware. And as our community relies on collective knowledge. When I was asked to write the book, I said, okay, but I think it would be better if I can ask other people to write specific chapters on areas of their expertise. So, we've got a chapter on the legal, backings behind open source hardware. We've got chapters on manufacturing. We've got chapters on documentation. There's all kind of everything that touches open source hardware, no matter how ancillary it is, it's kind of meant to be that all-encompassing, like, oh, okay, here's everything I needed to know to get started with an open source hardware project, or a deep dive into, question that I had about open source hardware. We hope that it's really a guide for any questions, and a guide for doing open source hardware. Although I will say now our certification exists, which is not in the book, so needs to be updated already.
Books always do. And you wrote a few chapters. One of them is about creating derivatives, and it defines what part of what we've talked about with the trademarks and the logos, and how to figure out how to properly credit someone else. It seems like that should be obvious, but in hardware, you're not putting their logo on your board in order to credit them. That's the wrong way to credit them.
Yes.
Do you have advice for proper attribution in hardware?
Yeah, I think the best place to credit somebody is directly on the product page. So, I imagine like hardware product pages eventually looking like those movie credits, right? Where you've taken so many different things and products have been just built upon and built upon and built upon, where you need to, credit a whole bunch of people. And I think that to me is really exciting. But yeah, I think in terms of where it should be, absolutely on the product page on the website. And the other place that it's really important is in the GitHub repository, either in the README file or if you've got a file on licensing, of course, make sure that the attribution is there. And here's the thing about attribution is you can't do it as long as you're not putting something like logo on your board. You can't do it too much, right? Like you can't put their name like this product was originally created by so and so. Like you're not going to offend anybody by doing that too much, right? So my advice on that is, do it in visible places and do it as many places as you think makes sense. So if think about the person who originally made the product and think about them coming to your website or GitHub repo or wherever they might land, wherever you think that person might land, make sure that they're credited.
Cool. And the last question I have for you, we aren't having an open source hardware conference this year because the whole Shenzhen plan didn't work out. But next year?
Yes. So we're totally bummed that our Shenzhen plan didn't work out. But the laws have changed and it turned out to be much more legal work than we had access to or money for. And so actually this is breaking news, but the 2020 summit we are looking at for the spring in New York City again. So we kind of wanted to go back to New York where it all started, especially for the 10 summit anniversary, and have it back at the origin spot. So we will be back in New York in the spring of 2020.
No date yet.
Not yet. We're looking at early April because we think that would avoid a lot of other conflicts. So if any of the listeners want to reach out to us with conflicts we don't know about in early April, please let us know. But we're looking somewhere in early April to avoid the other things like the first robotics competitions and Maker Faire and all the other conferences that happen in the spring.
All right. Do you have any thoughts you'd like to leave us with before we wander off to our weekends?
I would say, I hope that we can get to a place where people do care a little more about the IP of the product they're purchasing. And I hope we get to a place where people, when they're purchasing a product, make sure that they're either, purchasing the open source version or at least are educated on whether or not there's an open source version out there. And the last thing that I would love to say is if you've got an open source hardware project, please consider certifying it. It gives us a lot more data about our community and gives us numbers to work with, as well as protects your product a little bit more. So please consider certifying. We launched a new website recently for the certification. So it's all shiny and new and much easier to go through than the old website was. So if you haven't checked it out, please check it out. It's certification@oshwa.org.
Excellent. Thank you so much for being with us.
Yeah, thank you so much for having me.
Our guest has been Alicia Gibb, Executive Director of the Open Source Hardware Association, Director of the Blow Things Up Lab at Colorado University Boulder, and CEO of Lunchbox Electronics. Wow, we didn't even get to talk about that.
That's okay. It's the smallest thing I do.
I would like to thank Christopher for producing and thank Dave Young for some interesting questions. And of course, I want to thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on embedded.fm. It's a website. And now a quote to leave you with. This from John Green in the very quotable The Fault in Our Stars. I'm a grenade, and at some point I'm going to blow up, and I'd like to minimize the casualties, okay? Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.